The neutrino is one of the most abundant particles in the universe, yet it is incredibly difficult to detect. Neutrinos are important to study because they contain information about the phenomena and processes that give rise to them. This means that you can use them to learn about the origins of the universe. We tell you about all the secrets that neutrinos hold. Neutrinos are ultralight particles produced during nuclear reactions. Most of those detected on Earth come from the sun, which turns hydrogen into helium. But in the 1930s, it was predicted that the sun should also produce another type of neutrino through reactions involving carbon, nitrogen, and oxygen, so-called CNO neutrinos. It was not until nearly a century later that the Borexino detector first detected these particles. You might say now, what do I care about any neutrino? What does it have to do with me and my family? And now I will give you one dizzying fact. About 200 trillion neutrinos pass through your body every second. Until recently, it wasn't clear whether it had any mass at all. In recent years, it's become clear that it does, but it's very small. Its exact value is unknown to this day, and available estimates are generally summarized to the fact that the neutrino is about 10 orders of magnitude lighter than a proton. Approximately the same correlates the weight of a grasshopper, about 1 gram, with the displacement of the modern nuclear aircraft carrier George Bush, about 100,000 tons. The particle has little or no electric charge. Experiments have not yet given a definite answer, and of all the fundamental physical interactions reliably involved only in the weak and gravitational. Neutrinos are categorized into 3 generations: electron, muon, and tau neutrinos. They are usually listed in this order, and this is not accidental, so displays the sequence of their discovery. In addition, there are antineutrinos. These are antiparticles of 3 different types corresponding to the ordinary ones. Neutrinos of different generations can spontaneously transform into each other. Scientists call this neutrino oscillations, and they were awarded the 2015 Nobel Prize in Physics for their discovery. Neutrinos are the result of nuclear and thermonuclear, we will not separate them further, reactions. There are a lot of them, the elusive ones. According to the calculations of theoretical physicists, there are about 109 neutrinos for every nucleon, that is, proton or neutron, in the universe. Nevertheless, we do not notice it at all. The particles pass through us. As soon as it became clear that neutrinos, although difficult but still can be registered, scientists began trying to catch neutrinos of extraterrestrial origin. The most obvious source is the sun. It is constantly undergoing nuclear reactions, and it can be calculated that through each square centimeter of the Earth's surface passes about 90 billion solar neutrinos per second. Why do we study neutrinos in the first place? Experts have likened the search for these particles to the work of archaeologists, recovering prehistoric artifacts to understand what life was like back then. A better understanding of neutrinos could unlock the mysteries of other elements of astronomy and physics, from dark matter to the expansion of the universe. Studying the neutrinos emitted by the Earth can help us at least understand how many radioactive elements are in Earth's matter and where they are mostly found. There are different versions of the latter, starting from the fact that uranium and thorium, an attribute of the lower part of the Earth's crust, and ending with the fact that the sources of radiation during the formation of the planet sunk to its center. And there is a kind of nuclear reactor and periodically active. Accumulated decay products, when they get large enough, stop the chain reaction. Then, in a hot environment, they slowly diffuse upwards. They are lighter, making room for new portions of fissile material, after which the process starts again. If it is so, such cyclicity could help in explaining the changes of magnetic polarity of the Earth, and, we should think, in many other things. Also interesting is the question of the share of nuclear reactions in the total heat generation of the Earth. Recall that the Earth's bowels produce about 47 TW of heat per year, but scientists still have a vague idea of what part of this energy is radiogenic heat and what part is residual heat once released during the gravitational differentiation of the Earth's matter. How is this interesting to the average person? The technologies that are being developed to create modern experiments on neutrino physics are widely used in industry now, so that any investment in this area pays off. There are several experiments underway around the world, the scale of which is comparable to that of the Large Hadron Collider. These experiments are aimed solely at studying the properties of neutrinos. It is not known in which of them it will be possible to open a new page in physics, but it will be opened for sure. Thank you for watching this video to the end. Don't forget to like and subscribe to the channel to learn more about space.